Hello, boys and girls. It is Thursday, April the 2nd. We are on day 7 of the lockdown in South Africa. Current time 20 to 10 UTC plus 2. Surprise, surprise, our government hasn't released any stats for today. As we know from yesterday, they were going to embark on their mobile testing facilities and whatever. So either what they picked up has made them totally shit themselves and they don't want to share the results, or they really haven't embarked yet, or some shit is going on. But either way, our stats remain the same as yesterday, apparently. So we've had no infections since yesterday. Well, we've had no release of any data since yesterday. So I can only surmise that whatever fucking cock-up happened there, they don't really want to release. Interestingly enough, there was a big debate with this twit, Fakile Malula, who decided that, the taxis in South Africa can now go and carry full capacity of passengers, and they must issue safety masks to people or some sort of self-contained breathing apparatus. But the joke is they give the passengers the masks when they get on, and when they disembark, they take the masks back and give it to the next fucking bunch of passengers. Now, how fucking clever was that? Either way, by last night, he retracted his statement and has come out with a new scheme today. But I mean, this is the utter stupidity in South Africa. The other problem in South Africa is that these guys I have a suspicion they're not reporting on the true facts of things. Because if, to give you a good example, people in South Africa don't die of AIDS or HIV/AIDS. They die of AIDS-related illness like tuberculosis or pneumonia or something. Which is fucking stupid because we don't know what the real stats are. And if they're going to carry on with this in South Africa with COVID, what are we going to know at the end of the day? What is the reality of it? Are you going to be in they declare this epidemic or pandemic over at the end of the day, and you go to work and you're fucking paranoid because you don't know if somebody coughs to you, hit him with a baseball bat or something. I mean, the stupidity of the guys in cabinet sometimes is actually mind-boggling. But like I say, it's day 7 of lockdown. It's April the 2nd, 2020. And when I was filming yesterday's video, knowing my luck, typically I lost Eskom for the day, so I couldn't actually carry on with what I was going to do. So I still have to finish up a few things on our project before we go to the HMI stuff. So today I thought we'd take a break from the PLC HMI program and I'd show you an interesting little project that I'm working on for a colleague. Now, this is a very strange request. As far as I understand, there's one company that makes this sort of product, and it's not what we thought it was. So, this product that this colleague wanted me to make is known as a dip-proof inverter. Now, what we have is motor control centers. So if you want to think of it, it's a big cupboard full of motor circuits with the protection that controls the motors. So you would tell this thing start, the protection relay will pull in a contactor, the motor will run, the protection relay will look after everything, and if there's a fault, it will drop the contactor. But as in South Africa, as in most countries, we have dips in our power. And the point of a dip-proof inverter is to carry the contactor, to hold the contactor in. So for a few cycles, you can lose power, and the motor is turning under inertia, it doesn't stop dead. And as long as you lose power for a few cycles, you want to be able to ride through that. You don't want to trip your whole plant. If you don't have a dip-proof inverter on your board, obviously your contactors will fall out straight away and you will trip your plant and you could be losing millions and millions of rands or dollars an hour depending what your process is. So what they do is they put a dip-proof inverter in the board that you can. It's got a variable time setting, and you can take the control voltage input, which is normally 110 if you've done it properly, or 220. I prefer that they design with 110, and you will carry that 110 through a few cycles. Anything up to, normally up to a second or second and a half that you can set it for, but I would never set it that long, because why are you carrying, if you've lost your power for a second, if your power dips for a second or a second and a half, you've lost your power provider in general. Well, that's my reason. So anyway, my colleague came to me and said he's paying a hell of a lot of money for these things, and there's only one company he can buy it from. Would I look into designing something like that for him? And the more I dug into this thing, the more I realized that it is not a true full inline dip-proof inverter. In other words, what this thing does is it monitors the control voltage, and if the control voltage dips below a certain percentage, then this thing will switch in. So whatever noise is in the power is being passed straight through to the contactors until this thing kicks in, which to me was a bit of a it wasn't really my way of thinking. I would have preferred to take the control voltage, rectify it, create a DC bus. This is all straightforward. You would find this in any sort of drive circuitry or anything like that. Then on the DC bus, we put a whole bunch of capacitance, and then we invert it. That way we can control the output voltage level as well. So we have a true full online inverter, dip-proof inverter. And the point of controlling the output voltage would be so that we can keep it constant. So whatever noise, transient bullshit is coming through on the input, you will take out, and you will have a nice pure sine wave on the output. The other thing that I noticed with the product that these guys are making is it's not a true pure sine wave. Now this is a big fuck up for us, because my electrical colleagues, they don't care about contactors and things like that. Yes, they can handle nice square waves, whatever. But the problem is when they go and ask me to put whatever equipment I need in their bus communications, whatever I want. So I'm going to put in a nice 24 volt 110 to or 230, 110, 230 power supply to 24 volt DC to power my equipment, and when this dip-proof inverter kicks in, it fucking destroys my power supplies, and the guys don't understand why, and I keep going back and saying, but it's a square wave, it's not a pure sine wave. So that's where this project came about. So to make a change from yesterday, or from the past few days, sort of PLC programming and whatever, I thought we would have a look at the concept of this. So I'm using KiCad, and basically, just to make it neat, otherwise we'll end up with a whole bunch of rubbish on everything. I haven't completed the design. We will complete it together. I have done the first few steps. Basically, we've got our AC in. We got our rectifier circuit over here. Then we have active power factor correction, and I'll explain why we're doing that in a series. And then we're going to go to our pulse width modulation for our inverter, and then we basically go to our AC out. So there's 3 stages to it. We take our AC mains in, our control voltage in, 110 volt AC in. We rectified, we create a DC bus. Then we go and do some active power factor correction on it. In other words, we try, and because we're using switch mode to do this, we try and bring the voltage and current in line so that we can bring our power factor up. Why is that important? Well, think of it like this, without going into too much detail. If you had a beer, and in the beer glass you had some beer, and on the top you had the foam, in South Africa you're paying for the whole glass, so the beer and the foam. So you want more beer, in other words, more power that you can actually use, and less foam. And that's what we're trying to do with power factor correction. We want the whole glass as beer. That's what we're really trying to do. We want less foam. So without boring you to death and whatever, I thought we'd just have a look at the first part of it today, because I must still go on and complete all the PLC coding and stuff for our other project before we can get to the HMI. So just to lighten things up a bit today, I thought we'd have a look at this dip-proof inverter and my reasoning behind why I'm doing certain things. I am drinking coffee. I find myself doing a lot of things that I wouldn't normally do in this pandemic or shutdown period. I'm drinking a lot of coffee for some dark reason. Normally I'd be drinking beer. But it is a work day and it is rather early in the morning. It's only 10 to 10. And I can't even say the first aeroplane's flown over. I live not far from Lawrence area, but all the planes are grounded, so I don't even have that excuse. So anyway, coming back to our circuit, we have our AC in, basically a live, a neutral, and a earth. They will have to give me an earth reference, obviously. This live and neutral normally in an MCC is derived from the control transformer, so they will maybe have a 525 volt 3-phase AC busbar system, and they will put in a step-down transformer, which they normally do anyway, and that will take 525 down to 110 volt AC, and they will give me the 110 volt AC with live, neutral, and earth. What I thought was, let's design this for a universal input. In other words, 110 volts to 230 volts, straightforward with a bit of, tolerance. So we said we would go from basically our input voltage 80 to 270 volts AC tolerance. We would design it for 2000 watts or 2 kilowatts, and our peak current would be 35.36 amps, and we'll later on in the series we'll get to the calculations for this. So basically we take our live, our neutral, our earth into our rectifying circuit, and you'll notice I get 325 volt DC out with a 0 volt negative, and I carry my primary earth through. 325 volts, that's easy. Take the square root of 2, multiply it by your 230 or whatever, and you get your 325 volt bus. We then do our active power factor correction, so we put our 325, our 0 and our primary earth coming in, and then we go out with our 400 volt DC bus, the 0 volt negative, and our primary earth, and we do our pulse width modulation. So we take our DC bus, we're now doing pulse width modulation to get it into our H-bridge, and with its filtering to invert it back to AC, to convert the DC back to AC. We're using pulse width modulation because we don't know what the load is going to be. It's not always going to be a full 2 kilowatt, because not all your motors are running it all the time, depending on what the diversity of the board is. You might have a duty and a standby pump in the same board, so your utilization factor or your diversity of the board might be 50%, so we might only actually be using 1 kilowatt of the 2 kilowatt. But to make it efficient, we use pulse width modulation. So we invert it back to AC and regulated AC, and we'll get our live and neutral out again, plus the primary earth, and we'll take that to the AC out. Obviously what we will need to do is build a bypass switch over this for whatever reason. If they want to bypass the inverter, the inverter ideally is maintenance free, so I don't know why they would want to bypass it. But if the thing is, worst case, if it's defective or faulty, then we'll have to bypass it so that they can carry on running their plant, take this thing out, and off they go. So we'll just look at the first section today. So if I double click in here, here is basically straightforward circuit. Basically, I like to make little notes here, just for me, when I do calculations or whatever, I like to make the little notes. They are typically design requirements to me to remind myself of what I'm doing. So basically our life comes in through a fuse, 40 amp fuse. We have some mob protection, basically line to line, and then each line to earth. All the mobs are there is for any sort of surge, transient noise, whatever. They will open back to earth, to the primary earth. So any transient noise that comes through, all these mobs are doing is shunting that transient or noise back to earth. We have an NTC, 33 ohm NTC in. That's for our soft start, because obviously later on we've got some capacitors and whatever, so we don't really want to blow our fuse and whatever. We want to limit that inrush. We're using the NTC for that. Negative temperature coefficient resistor. This funny looking arrangement here, just a capacitor, resistor with a common mode choke. It is just for filtering out our noise. We don't want our switching noise to go back into the mains, and we don't want whatever crap is happening there to come into our circuit. So we are not letting our switching noise go back in. Again, we have some more filtering. Obviously these capacitors are safety related caps. You can see X1 type line to line. In other words, that is an X1. These are line to ground. So these inductors, capacitors and resistors again give us filtering. So we have our filtering, and then we just have a full wave bridge rectifier. Nothing fancy, really nothing fancy to it. So input circuit, really our protection with our startup and a lot of filtering, and then our full wave bridge rectifier. Very, very simple. You'll see a lot of these things like the NTC, capacitors, resistors. I've already calculated the values. We will get to that. What you will find is things like this capacitor and that resistor, and the same with that one, are typically common values. So you will find that these capacitors come in two values typically, and you will use them in a combination: 100 nano, 4.7 nano, and you with the 100 nano you would use a 470k resistor. You'll have to just take my word for it, but you will typically find these combinations used together. We'll do the math at a later stage and show you why it is all the frequencies that they're using. The common mode choke, we'll get to that. This is going to be a lot of the things in, not a lot, things like the common mode chokes and things like that are going to be custom wound. You're not going to get, and the switching transformers, because you typically don't get those things standard off the bench. It's not a standard thing that you just go to RS Components or whatever and say, oh, give me one of these. No. Because you are designing this for your specific requirement, and you will see that later on when we go through the calculations. So that's typically our input circuit, our rectifying circuit. Nothing to it. Fuse protection, startup protection, transient protection, noise filtering, rectification. Really not much to it. If we go out of here, we'll just briefly look at the power factor correction. Don't worry about all this, we will go into it. I am using UC3854. Let's just show you the data sheet for that. I've learned that I can just switch it off like that. Oh, I'm so happy. Basically, the UC3854 is a high power factor regulator. Control boost pulse width modulation to 0.99 power factor. Limit line current distortion to less than 5%. Worldwide operation without switches. Feed forward line regulation, average current mode control. And we'll get to why when we go to the second part, why we're using average current mode, low noise sensitivity, low startup supply current, fixed frequency, pulse width modulation drive, low offset analog multiplier divider, 1 amp totem pole gate driver, and precision voltage reference. Now that actually means Greek to you and to a lot of people. I think this is written by some bunch that converted the Chinglish to English, but basically the UC1854, 3854 in our case, provides active power factor correction for power systems that otherwise would draw non-sinusoidal current from sinusoidal power supplies. Again, what they're talking about is they're saying that we are distorting the sine wave. The device implements all the control functions necessary to build a power supply capable of optimally using available power line current while minimizing line current distortion. To do this, UC1854 contains a voltage amplifier, an analog multiplier divider, current amplifier, and a fixed frequency pulse width modulation. In addition, the UC1854 contains a power MOSFET compatible gate driver of 7.5 volt reference, a line anticipator, load enabled comparator, low supply detector, and overcurrent comparator. And those are important. We will see when we get to that circuit why we want to do those things. It uses average current mode control. To accomplish fixed frequency current control with stability and low distortion. Unlike peak current mode, average current control accurately maintains sinusoidal line current without slope compensation and with minimal response to noise transients. So that's why we're using average current. We'll go into detail when we get to that. Blah-de-blah. Important. Can be used in single and three-phase systems with line voltages that vary from 75 to 275 volts and line frequencies across 50 Hz to 400 Hz. Well, we want to operate with 50 Hz to 60 Hz, 110 to 30, so that's where we're getting our 275, 75 to 275. Features low starting supply current, and you get them in plastic, 16-pin plastic and ceramic dual inline packages, which was important to me. I didn't want to go surface mount if I didn't have to with these sort of things, so because I don't know what cuck I'm going to make, and so we can rather slot it, put it in its own thing, and if it fails we can pull it out. Block diagram. I think fancy supply voltage, maximum rating 35, drive current continuous 0.5 amp, 50% duty cycle, 1.5 amp input voltage, release sense 11 volts, peak limit 5 volt, 10 milliamp input current, can operate. No, where's my maximum operating temperature? That's storage temperature. And then we've got all the electrical characteristics. But what was important, I don't know if it's in this data sheet. No, it's not. Let me go through our, unless I'm blind. I think that was it. No load, VA. Minus 55, temperature 225. That's gate drive. Okay, that's not what I'm looking for. I don't think it was in this data sheet. No, it's not in this data sheet. No, unless I'm completely blind. But basically, the operating temperature of this was such that I didn't need to implement forced cooling within the system. So that was very important to me. No. Okay, so it's not in this data sheet. I'll have to look for the other data sheet. Anyway, that is just a little preview to let you know what it is that I am working on. These are not work related. Well, it's not what they pay me for. This is out of my works. Well, it's for work, but it's not work related. So just to break the monotony with the PLC programming and HMI programming, I thought we'd have a look at something else and have a little bit of a rant about these idiots that are not giving us any specs or any stats. Is there anything in the news updated? No. All these twits are giving us is like a running commentary about the last 4 weeks. 4 weeks after the first COVID-19 case, South Africa is coming to terms with new reality. Nothing. SA agrees to provide repatriation charter flights to various countries. COVID-19, quick insight from the 1st of April. Today is the 2nd of April. And this was published an hour ago. We're the 2nd of April, and we're fucking 24 hours away from this snot. Makize, mass COVID-19 testing aimed at reducing local transmissions. South Africans stranded abroad, hoping government can assist them to return home. Some spaza shop owners are already feeling the pinch of COVID-19. No, fuck, nothing. Nothing. Lockdown. City of Cape Town expects to lose up to 3 billion rand per month in unpaid bills. This is the best one that I heard yesterday. The public sector units to take the government to court over 0% wage increases. We're in a fucking financial crisis. Our rand is being declared junk. We're losing, I don't know how many billions of rands a day in tax because our mining houses, the furnaces, any non-essential manufacturing business in South Africa, so furnaces that smell platinum, whatever, they are all in care and maintenance. They are not running. So you're losing that fiscal income. But no, our public sector, the fucking idiots sitting that are government employees are on strike or going to strike because they want an increase that they negotiated 10 years ago. We haven't got the fucking money to pay them. Besides, you're employing 10 or 100 to 1, 100 people to do one's job or 10 to do one's job. And they still want an increase. I mean, how fucking far do you want to push the country into the ground? No. opinion, the world needs to declare bankruptcy. No, not us. We. Good Lord. Sometimes I wonder with the South Africans. Okay, we don't care about sports, and I don't care about the lotto results. That was EWN, Eyewitness News. News 24. Lockdown, Skop and Dorner. Experts say cops, army can have less. Oh, fuck me. Whatever. Skop, Skin and Dorner for my overseas viewers. Skop, kick, skit, shoot, Dorner. Well, you can fight, punch him. No. News you should know. 87,000 hospital beds available for coronavirus patients. Numza fears hundreds of jobs could be cut as Commerce starts restructuring. Who cares? Increase of 27 coronavirus cases may be calm before devastating storm. When was this? Yesterday, 8. Okay, so yesterday evening at 9 o'clock, 20:55, it had risen to 1380, with still 5 deaths. So if I put in the numbers here, if you don't mind. Okay, I don't know how many people they've tested. That is a 2% day-on-day growth from the 1st of April, if I believe their numbers. I can't tell you how many tests they've done, so I can't tell you what the infection rate is, and I can't tell you how many people they've tested or anything like that. But if that is correct, it went from 1353 on the 1st of April to 1380, and that is a 2% day-on-day growth. Again, we don't know how many people they have tested. He's leading with, I don't care about the provincial, he says 40, okay. 44 to 20 tested. So if that is right, let's put it in. 44 to 20 will give us if they've tested 44,220 people, that means based on the population of what they've tested versus infected, it means our infection rate is 3.12%. So in other words, what I'm looking at is the number of infections versus the number of tests as a percentage, and that means our infection rate is 3.12%. You can't look at the infections versus the population, because then that is just a very skewed, rubbish number. You need to look at infections versus what they've tested, and that will give you a better idea. That means our infection rate is 3.12%. Our population remains 60 million. That means the percentage of the population that we've tested is 0.07%. Our day-on-day mortality, it's people that have died, which is basically the number of deaths divided by the number of infections, is 0.36%. So we're still a little bit skewed. We're not in line with the world, or what happened in Italy and those places, because there roughly the mortality rate is 10%, and the infection, it's 10%, and the infection rate is roughly about, I can remember, is about, I think it was 60% or something stupid that I saw. Okay, But either way, that was last night at 20:55. So I'm just going to make I can't unfortunately show you the Excel spreadsheet because the software I'm using is OBS Studio, and it doesn't allow me to do a window capture. What I can do is probably just take a video capture or a screenshot of it and paste it into Paint to show you what I'm talking about. So 2020 0401. So I'm just putting a comment in. So basically what I do is I have a column for lockdown day, the date, the number of infections, number of deaths, the day on day percentage growth, comment. So when we went from 2 deaths to 1, because one of the deaths was from other causes, the number of tests carried out, what they're releasing to us, the infection rate, our population, the percentage of the population that's been tested, and the day on day mortality. So what I will do is, as we get more data, then what I will do is every morning just include, a screenshot of my spreadsheet. What else in news you should know? How to cope with feeling stressed and overwhelmed while working at home. Oh, good Lord. If you're not used to working at home, it's easy. It's like another work day. You get up at the same time, you do the same routines, get dressed like it's a work day. Don't sit in front of your desk in your underwear or whatever the hell it is. Treat it like any other work day. Just behave like a work day. I'm lucky in the fact that I get to work a lot from home, so this is nothing new to me. But just treat it like another work day. Blah de blah. From roof hoppers to bar burglars, 15 arrests in Cape Town CBD. This is stupidity. They should have. The reasoning in South Africa why you're not allowed to, why they've locked down on booze and things like that is they are scared of the increase in domestic violence. The problem legally, and I hope somebody takes this and challenges this, is you cannot link directly. The case, you have to think of case law. Lawyers will know this better. I was listening to a very good argument about this yesterday. You cannot directly link booze to domestic violence. There's no court case that's whatever they call it that's linked this. And if somebody gets one of these lawyers or whatever that runs out of booze and gets a bit thirsty, decides to take it on, I think the Constitutional Court or High Court will reverse it, and they will actually be forced to open the bottle stores again, which would be a good thing. The same thing with them stopping cigarettes. I mean, it's utter stupidity. What? If I'm sitting at home smoking my cigarette, what the fuck has it got to do with them? The other stupid things that they lock down on is condoms. I mean, what the fuck? We've got a lot of AIDS infections in the country. These people are whatever. They're doing whatever, regardless. Now you're creating more problems. I don't want to blush. I don't really want to go into that, but yeah. No, okay. Yeah. Yeah. Africa, only in Africa. Okay, more sports, business. Coronavirus dividends are falling should executives also take pay cuts. Nothing really interesting. Facebook is rolling out a feature that allows people to request or offer help to neighbors. How to cope with feeling stressed? Oh, good Lord. Without tourists to Thailand. Taxis can now be fully loaded if everyone wears hard-to-find masks. And this is utter stupidity. Really, the people that need those masks are doctors, nurses, people that are dealing with this and treating it. No? Whatever. Entertainment. In the midst of worldwide lockdowns, Tiger King may be what keeps us sociable. I don't know if you've seen this documentary. Look, I'm a cat lover. I'm not a fan of petting zoos and shit like this. But what this Tiger King is about is these bunch of idiots in the States that rear these cubs as petting cubs, tigers and things like this. And that's purely what they're rearing it for. And it's this whole American hillbilly outback bullshit about these oaks that don't like each other, and then the one oak wants to assassinate this one. And look, if you want to watch a lot of drivel, really waste your time. I think there's 8 or something episodes in it, and you've got at least a case of beer, because you really have to drink yourself into stupidity and just sit there mindless to watch it. It's crazy. It's mind-boggling that it's actually allowed to take place. Anyway, enough of a rant from me. I thought it'd be nice just to have a bit of a break from the usual stuff. As always, I will keep updating the spreadsheet as I get the numbers. But for you guys, if you like the video, if you want to comment on it, if you don't like my sense of logic or humor or whatever, feel free to drop a comment. I mean, I enjoy reading the comments when I get them. I like the interaction. From my side, please don't do anything stupid. Stay home. If you're on lockdown, stay safe. The guys that are working in the essential services, you guys need to take all the care that you can. From my side, we'll catch you next time. Cheers.